This is the Masking Handbook for Audiometry. In this video, we'll be looking at using the Plateau method for masking with unilateral sensorineural hearing loss. Here we have a unilateral hearing loss in the right ear. We have unmasked bone conduction done with the bone conductor on the right side. They are unmasked, so we don't know which ear they're coming from. In this case, we're using TDH-style supraoral headphones, and the difference between the unmasked air conduction thresholds on the right side and the thresholds on the left ear all exceed the minimum possible interoral attenuation values for these phones. We can't be sure that the right ear is hearing any of these test signals. We'll have to mask the left ear to confirm if the right air conduction responses are accurate. Let's use the Plateau method and start at 1000 Hz. Here is our IML. We have a 5 dB compensation due to the hearing threshold of the left ear at 1000 Hz. We also added 10 dB as an active masking level. The total of our initial masking level is therefore 15 dB. Because we're dealing with air conduction testing, we don't have to compensate for the occlusion effect. When we deliver the IML to the left and retest the right, you see that the threshold did shift. In this case, it changed by 10 dB. This tells us that the initial unmasked right ear threshold was actually being heard by the left ear. We masked the left ear and the hearing response changed. This means that the initial threshold was due to cross-hearing of the tone in the left ear and not coming from the right side. We don't accept this initially masked threshold. In order for us to accept a masked threshold, we need to be able to increase masking levels over several steps and have the test ear threshold stay the same. When this occurs, it proves to us we've masked appropriately. So now we start the plateau portion of the process by increasing the level in steps, and we'll use 10 dB steps. Let's add 10 dB of AML to this initial level and retest. Once this was done, the right threshold response changed again. We're confirming that the 1000 Hz test signal has not yet been heard by the right ear. If it had been the right ear, the response wouldn't change as the masking level increased. Because masking noise was delivered to the left ear and should only affect the hearing of the ear it's delivered to. We're confirming crossover and cross-hearing in the left ear when this happens. Let's continue to plateau. There's 10 dB of additional active masking. The right threshold shifted, but it did not shift the full 10 dB, which was the masking level step increase. Sometimes it can be a good sign when the threshold shifts at a smaller amount than the masking increase. But let's add 10 dB and see what happens again. The threshold did stay the same, so we have two responses at this 80 dB HL level. As the masking increased, the threshold did not shift. That means the left ear could not have been hearing that test tone in all likelihood. So it must have been the right test ear. If it had been the left ear, then the threshold would have changed as the masking increased. Let's just add another 10 dB and retest. No change again. At this point, we've confirmed that we're on the plateau, confirming that it was our right test ear that heard these 80 dB test signals. Another way to think of it is that we've confirmed it was not the left ear that heard them. We can officially label this as a right masked air conduction hearing threshold. This is the Masking Handbook for Audiometry. If you liked this video, you'll love the handbook. For more resources on masking and to learn how to purchase the book, check out maskinghandbook.com.